In category theory, there are two very important constructions: pullbacks and pushouts. But how do we express them in homotopy type theory? Let's start with a pullback. Suppose we had the types A, B, and C. And suppose there is a function f from A to C and a function g from B to C. We can then think of the pullback almost like the products of A and B, with projections to A and B. We define it as follows. Given a term x in A and a term y in B, we can construct a term in this pullback as long as f of x is equal to g of y. If C were the unit type, f of x would always be equal to g of y, and the pullback would be equivalent to the product. We can also, for example, let C be equal to B and G be the identity function. The terms inhabiting this pullback would then be points on the graph of fx equals y. But what about pushouts? Well, let's assume again we have the types A, B, and C, but this time f maps from C to A and G maps from C to B. The pushout is then defined as follows. We have a left injection from A to the pushout. We have a right injection from B to the pushout. And we have a dependent path constructor glue, such that given an x in C, there is a path from the left injection of fx to the right injection of g of x. If C were the empty type, we wouldn't need to add any paths, and we would simply have the coproduct. If C were the unit type, we would be constructing a path from exactly one point from A to one point from B. In other words, we would be constructing the wedge sum. We now know how to construct pullbacks and pushouts in homotopy type theory. Thanks for watching.